In this video, I'll find the work that's needed to take two protons that are initially infinitely far apart, bring them within 1 millimeter of each other. And then if you released both of them, how fast would they be moving when they would get infinitely far apart? So here I've redrawn the protons in the position when they're closest together, with a spacing of 1 millimeter. I'm going to change it to 0.001 meters, so I don't forget to put everything in SI units. Alright, so I know R when they're together. The initial and the final R, the distance between them, is infinity. So infinite meters. Charge of each, charge of a proton, mass of each is the mass of a proton. First question was, how much work does it take to bring them together? And the second question is, what's their final speed if you release them after bringing them together? So first, how much work to bring them together? Well, work is a change in energy. So the change in, here we've got electric potential energy. That's Q times delta V. We have two ways to find delta V. One is valid only for a uniform electric field. We're dealing with point charges, not a uniform field, so we can't use that. What we have to use is the V is KQ over R. So what we need to do is we think of both of them being infinitely far apart, then we bring one in. To bring one proton in from infinitely far away to here does no work because the other proton is still infinitely far away. So to bring one in takes nothing. But this one that we bring in then creates a voltage. It creates an electric potential at the position that we want to bring the other one into. So what we need to do is think of bringing the first one in, taking zero work, and then all the work is being done on the other one as you bring it in. So the charge of a proton times delta V, that would be V final minus V initial for one of them. So this would be Q times KQ over R. This is the R final when we're bringing them together. So this is the R together minus KQ over R final. R final is infinity, so this goes away. So the change in energy is KQ times Q, Q squared, over R together. 2.3 times 10 to the minus 25 joules. So that is the work that was done. That's the work to bring them together. Now, what about the final speed for each? This work was done bringing them together. When you release them both, that energy that was stored up in them changes completely to kinetic energy. And since the system is symmetrical, you know that both are going to end up with the same amount of kinetic energy. So K final for one of them is 1/2 times this 2.3 times 10 to the minus 25 joules, or 1.2 times 10 to the minus 25 joules. K is 1/2 mv squared. So we know that V is 2 times K over m square root, which is 2 times 1.2 times 10 to the minus 25 joules over mass of a proton, 1.66 times 10 to the minus 27 joules. 11.8 meters per second.